So today I'm going to do this video about area and volume. So in this particular thing, I'm going to do all the theory parts related to this objects which we can find in the area and volume lesson. And in the second part of the video, that means not this video, the next video, I'm going to discuss the questions that are coming under this, and we will be discussing how to solve them. Right. So already I have done the area of volume, the area and the volume of cylinder in one of my previous videos. So I'm not going to go there. I'll just write it down here. So when you consider a cylinder with radius r and height h, so the area of the two circles will be phi r squared and phi r squared, and there's this curved surface which is, when we take it apart, it becomes a rectangle where this length will be 2 phi r. The circumference of this circle will be the length of this rectangle and the height will be h. So here the area is 2 phi r h. So total surface area will be 2 phi r squared plus 2 phi r h. And also the volume of this particular cylinder will be area of cross section into height or the length, height or length. So volume will be, here the cross sectional area of this thing is phi r squared. So phi r squared into h, the height h. This is the total surface area, and this would be the volume. So what I want is, so whoever is listening to this video, pause at this position, draw this, write this down. So I am making a short note here. So I want you to pause the video, write down the equations and continue. Right? Right. Now next is, let's consider in a cylinder there could be another one where you cut a cylinder in half. A cylinder in half. So you will get something like this. Something like this, where this would be r, the radius. So this will be 2r, the diameter, and this will be, now I have put it sideways and I have drawn it. So this will be the h. මේක තමයි h එක. හරිද? දැන් මේක අතරම මම පුළුවන් තරම් සිංහලෙන් සමහර එක්ස්ප්ලেইন කරන්න බලන්න, සිංහලෙන් බලන්න දරුවෙක් තුනක් මේක තේරුම් ගන්න පුළුවන් වෙන්න. එතකොට පුතේ මේකේ total surface area ගන්නකොට මේකේ පෘෂ්ඨ වර්ගඵලය ගන්නකොට හරිද? එනකොට ඒකේ the area, so there's this half circle. Total phi r squared into half. Natham, can you remember when we were doing sectors, what we have done? If there's this radius here, if this angle is 180, the area will be pi r squared into theta over 360. So here pi r squared into 180 over 360, which gives pi r squared into half. That's how we got pi r squared into half. And there are two of those on the either side, right? There are two of those, plus then there is this half of the curved surface. So the curved surface is 2 pi r h and half of that, and plus there is a new surface on the top. If this is a solid, there is a new surface 2r into h. Now if we simplify this one, 2 and 2 get cancelled, so pi r squared plus 2 and 2 get cancelled, pi r h plus 2r h. Let me write this again. Pi r h plus 2r h. So this is the area. If you consider the volume will be half the volume of the cylinder. So volume of the cylinder is pi r squared h and half of that. So volume will be pi r squared h by 2.
By 2.
Here volume is pi r squared h by 2. Right. So this is another solid. Write this down as a short note. Then I go for the prism. So if you take a prism is something like this. Let's say it has length A here, length B here, and this length is C, and this perpendicular height is H, and this length is L. So here total surface area will be So there are two triangles where the perpendicular height is H, and here the base according to this diagram is B, and there are two of those, and there are rectangles where this one is B and this one is L, and there's another one C and L, and there is another one A and L. These ones, can you see? There's a rectangle on the other side, there's a rectangle this side, and there's a rectangle down side. So here half into base into perpendicular height, two of those, here B into L, here C into L, here A into L. So total surface area will be here 2 and 2 gets cancelled. So BH plus BL plus CL plus AL. But is this what do you call a standard equation? No. This is, I'm just explaining this, right? Because this may change according to triangle. It can change sometimes. If this is isosceles, right? If these two sides are equal, what will happen? Then these two here, two of the rectangles become equal. right? Let's say it's a equilateral triangle where the three sides are equal. Then what happens? Then all these three rectangles will have the same area, right? So this is just the basic equation, right? So write this down, copy the equation, highlight the equation. We are in the move of making a short note, so write this down. Then let's consider the area of a prism. So this is the prism. So as earlier also, as in the cylinder, here also the volume. The volume will be area of cross section into the length. So here. Now if this height is h, the base is b, right? The volume will be half into b into h, cross section into the length. This would be the volume of a prism. Right. Then let's consider the next object. What's that? Let's consider the pyramid. I'm going to consider a square pyramid. That means here this base lengths will be A and A. And let's consider this is h, the height is h, right? So, and also this is L. And by the way, I have discussed about this pyramid in one of my previous videos as well. So you can go through that. And it's under the heading why passing max is compulsory. So under that, while I am talking about that point, why passing max is compulsory, I am also discussing this pyramid. So in the pyramid, now we have 4 triangles with perpendicular height L and the base length A. There are 4 of those, and there is this square with A and A base. So total surface area would be half into base into perpendicular height, 4 of those, plus A into A. So here these two get cancelled. 2AL plus A square. That is the total surface area. And also volume. Volume equals, we say that volume of a pyramid equals to 1/3 the volume of a cuboid where the height is h and the base lengths are A and A. Let's say this one is h. So volume of the cuboid will be A into h. Length into height. So volume of the pyramid. Here there is a pyramid here. Can you see? The pyramid is, I have drawn the same pyramid inside this cuboid. So I have considered cuboid which are having the same dimensions, right? the perpendicular height is h and the base lengths are a and a. So here the volume will be 1/3 of that. So 1/3 a squared h v equals 1/3 a squared h equals 1/3 a squared h. So this is about the pyramid. So here what we are trying to do is we are trying to make a short note. The questions may be really different, right? There is a vast area where we can do the questions in different modules. But here first we'll write down the area and volume equations. We'll first derive them, because just remembering these equations, it won't do any good for you, right? You have to understand how these equations get derived, right? Then you can just make it yourself as well. Now let's say you don't know the area of a pyramid, but if you know the concept is what? There are 4 triangles and there's 1 square. If you add the areas of the squares plus the area of the base, then we can find the area of this pyramid. Right, let's consider the sphere after that. Let's say there's a sphere with radius r. So the area of the sphere will be 4 pi r square. So you have to remember this equation, 4 pi r square. And the volume of the sphere. Now here in this case, there's no way that we can derive this equation. Derivation comes under A levels. But anyway, the volume will be 4/3 pi r cube. Volume of a sphere. Then when we are doing questions, we will come across something other than this, that is the hemisphere. Hemisphere is half of a sphere. So let's say this is R. So there are 2 surfaces. One is this circle on the top, and there's this curved surface. So total surface area of this thing will be, total surface area would be, the top surface will be pi r squared plus this curved surface will be half of 4 pi r squared. So these two get cancelled. 2. So you get pi r squared plus 2 pi r squared. So that would be 3 pi r squared. Whole surface area. Right? If you consider the volume of this thing, volume will be half the volume of a sphere. So volume of the sphere is 4/3 pi r cube. So half of that. So we cancel. It will be 2/3 pi r cube. Volume will be 2/3 pi r cube. So I wanted to write this down as well. Volume of sphere is 4 pi r squared. Volume of area of a sphere is 4 pi r squared. Volume will be 4/3 pi r cube. If you consider hemisphere, total surface area will be 3 pi r square. But what's important is not this equation. The most important thing is how you got that equation. That is by adding the top surface of the hemisphere, that is a circle, and the half curved surface of a sphere. So you get 3 pi r squared altogether. Right. The last one we will be discussing is the chord. Let's say this has a sound height L, perpendicular H, and the radius R. So here the total surface area would be, there's this curved surface and there's this bottom, right? So the curved surface will be pi r L plus the bottom surface will be pi r squared. So you can take this pi and r out and write L plus r as well, or else just remember total surface area is pi r L plus pi r squared. And the volume is, it says that volume of a cone will be 1/3 the volume of a cylinder with the same parameter, that means the same radius as well as the height. So if there is a cylinder with radius r and height h, then volume of the cone will be, we know that the volume of the cylinder is pi r squared h, 1/3 of that. So 1/3 pi r squared h. So these are the two equations. Pi r L plus pi r squared, and the volume will be 1/3 pi r squared h. So we discussed the sphere, the cone, the pyramid, cylinder, and the prism. And also specifically we discussed half of a cylinder, that is half of a cylinder, as well as half of a sphere, which is a hemisphere, and also we derived the equations for that. So now the important thing is we have to understand how we derive these equations. How did we derive these? Because the questions may be different from each other, right? Sometimes there may be questions they are asking only the curved surface. Let's consider cylinder. Sometimes they may ask us, they are going to cut a barrel, so find surface area. Then we have to understand that there is no top surface, there is only a curved surface and the two semicircles on the lateral sides, right? So in this video we were discussing how to find the area and the volume of different objects. So from the next video we will be discussing the questions, mainly the examination questions related to these objects.